to our podcast today. For those who don't know us, EPS is the world's leading provider of open networking solutions. So what we do is we partner with the best vendors on the hardware side and the best vendors on the software side, and we offer a one-stop shop for our customers for all their open networking needs. And today, I'm delighted to be joined by three of our premium and longest standing suppliers to talk about the launch of our new 400 gig ZR Plus networking bundle that combines a switch, a 400 gigabit ZR Plus optic, and an operating system to make it all work together. So with that, I'd like to introduce you to our vendor partners. So for the switching component, we're joined by Nanda Ravindran from Edgecore Networks, based out of Bangalore. Nanda is the VP of Product Management at Edgecore and is going to talk to us today about the offering that Edgecore have in the 400 gigabit space. On the optics front, we're joined by Gert Sarlet. Gert is the Director of Product Management at Coherent, based out of Sweden. And Gert is going to talk to us about the new 400 gigabit Coherent products that Coherent have launched into the market. And finally, the network OS that makes everything work together is provided by IP Infusion. And we're joined by Victor Khen. Victor is the Marketing Manager for Partners at IPI, and Victor is based out of Taipei. And Victor is going to talk to us today about IPI's latest version of OCNOS that's going to make this whole bundle work together. Guys, you're very welcome to our podcast. This is the latest in a series of podcasts that the EPS marketing team have produced over the last number of years. You can find all the old podcasts on our website at www.epsglobal.com. But this is the first time we've combined Edgecore, Coherent Technologies, and IPI all in the one podcast. And I think that gives us a great opportunity to try and answer any questions that customers might have in relation to combining these products together. It's great to have you all together under the one podcast umbrella, so to speak. So I'm really looking forward to our discussion today. And if I can, Gert, I might start with you. And what I was going to ask, Gert, is there's been a lot of talk in the market, I guess, over the last year or so about 400 gig ZR Plus optics. Well, can you tell us a little bit about why these products are a game changer in the market in terms of what do people have to do before to build a coherent transmission system, and how does this make it a lot simpler to do that now?
Yeah, sure. Happy to address that. These 400 gig ZR Plus optics are really changing the way you can build an optical network. If you go back a few years, there were essentially three pieces of equipment that you or three layers in your network that you needed. You needed the switch or the router, managing data at the digital level. Then you needed a transponder or a muxponder, which takes that digital data and converts it into what is essentially an analog optical signal that's suitable for longer distance transmission. Typically, that signal is also colored, which means it has a specific wavelength, and then you can combine multiple wavelengths onto a single fiber to maximize the utilization of the capacity of your optical fiber. And then there's the actual optical layer, which is obviously the fibers. It's any inline amplification that you need to maintain signal level over longer distances. It's also all the elements that then manage the signals at the optical layer, at the wavelength level. So multiplexing, demultiplexing wavelengths onto a fiber, or also switching wavelengths in what is called a reconfigurable optical add-drop multiplexer. So those were kind of the three basic elements. What is happening now with these new pluggables is you're essentially eliminating the middle part of the stack there, the transponder, muxponder, and you're importing that functionality into an optical transceiver that can plug directly into the switch or the router. And that's being enabled by just technology, a number of technology advances. So one of the key building blocks in the transceivers for long distance communications is a digital signal processor. These used to consume tens to hundreds of watts of power, making it prohibitive to implement this in a small form factor transceiver. But now with advances in CMOS technology, the power consumption has come down dramatically. There's also been a tremendous effort in the industry to standardize the optical specifications, making sure that if you buy a transceiver from vendor A or vendor B, that those transceivers will actually interoperate on the optical link. So that again allows you to then plug optical transceivers from multiple vendors into the switch or the router. And then the third aspect, which I'm sure Victor will care about a lot, is the standardization on the management interface, making sure that all the equipment and all the transceivers speak a common language, so that IP infusion software can manage not only a transceiver from Coherent, but also from any number of other vendors.
Right. That's great. Thanks for that, Gert. And Victor, maybe to you then, could you talk to us just a little bit about what this 400 gig solution means just from an IP infusion perspective?
Yeah, sure. Thanks, John. So I believe, as most of our partners already know, the qualification of transceivers is a very time and resource intensive undertaking, and especially when we talk about the ZR plus transceivers, because the process requires more sophisticated equipment, right? As now we not only test the performance and stability, but now we also do the quality of signal transmission testing over long distances. And at the same time, just as Gert mentioned, we also do integrate the different management mechanisms for tuning of these transceivers. So it all makes it much more complex, time-consuming, and much more expensive. And but yeah, as IP Infusion, we do pretty much all of this testing to ensure that it all works together. And we are very glad to have partners like Edgecore and Coherent who always work with us and offer us with the real-time support. And this enables us to guarantee the meticulous validation process to validate these transceivers and ensure the robust data transmission. And also because of that, we can offer a comprehensive support for these critical components. Yeah.
Super. Thanks, Victor. And then Nanda, from the Edgecore Networks perspective, what kind of design considerations have your switches and routers had to incorporate to kind of take advantage of the capabilities of these 400 gig optics?
Yeah, thanks, John, for having me and Edgecore. So coming to the design considerations for the switches and routers to support ZR plus transceivers, especially the 400 gig ones. I mean, it is, when we start designing a switch or a router, it's one of the key design criteria that we look at. And the obvious ones are, of course, the power. These transceivers consume more power. And also the thermal design of the box or the white box itself. So depending on the number of ports that need to support these high-powered transceivers, we design a power plant and the PSUs to handle and support that power. And the thermal design, I mean, these transceivers, especially the 400 gig ZR plus, consume a lot of power and dissipate a lot of heat. So the thermal design is very critical. We need to cool these transceivers. and the selection of fan modules, the layout of the board itself, both from a thermal and power standpoint, becomes very important, and our designers pay a lot of close attention to it. I mean, these are very obvious design considerations, but from a customer point of view, these transceivers are very expensive, right? If you fill these 400 gig transceivers in one of our switches or routers, you will look at these transceivers being the biggest investment for the customer, from a customer point of view, more than the switch itself. So we have also put some thought and care into how do we protect these transceivers. So we have some special circuitry within the box that if something goes wrong, we trip the power and ensure that the transceiver is protected. A lot of thought goes into how do we ensure that a wrong transceiver is plugged in, or if something goes wrong in the transceiver itself, we protect the other transceivers that are adjacent to it and plugged in very closely. So having said that, for this qualification with the Coherent transceivers, customers deploying it, they can be assured that all the functionality and the performance and the efficiency that is expected has been done in this integration and the testing that we have done.
Great, thank you very much, Nanda. And Gert, we know that there's lots of optical transceiver options out there in the market, but what advancements in Coherent's 400 gig optics kind of set you apart from other solutions in the market? I'm talking about things like maybe reach or power or signal integrity. Mm-hmm. This is the opportunity for you to do your sales pitch.
Yeah, thank you for that opportunity, John. If you look at where this whole revolution started, is really in the OIF 400 ZR project, which was launched on behalf of some of the hyperscalers, Microsoft in particular, who were looking for a solution for very high capacity point-to-point links over distances up to 100, 120 kilometers. The solution that the industry came up with was really tailored to that specific application. And one of the disadvantages, if you then go and look at traditional way of building optical networks, was that those transceivers had low output power, minus 10 dBm. Whereas if you go and look at the optical layer that is in typical carrier networks with muxes, demuxes, ROADMs, they've all been designed around traditional optics for line-side communications that have high transmit output power around 0 dBm. So one thing that we focused on when we developed our ZR Plus transceivers at Coherent was to enable us to achieve those higher launch powers and be so to speak, backward compatible with the brownfield, with all the equipment that's already deployed in optical networks. So we could take that technology that was tailored for one specific application and apply it to a much broader set of applications. So the high output power is very key. One of the other ones that's also very important is the transmit optical signal to noise ratio. In order to achieve the high output power, you have to integrate an optical amplifier into the module. And amplification gives you a power boost, but it also adds noise. And we took special care into our design, taking advantage of our capability to monolithically integrate the amplification with our modulator in indium phosphide technology, that we also achieve very high transmit OSNR, transmit optical signal to noise ratio. And that is very important when you're combining multiple signals in colorless network architecture where there's no optical filter when you're combining, because then the noise from the different sources just stacks up. So transmit OSNR is very important in that regard. It also means that we're starting with a much lower noise level out of the transmitter than competing solutions, which means we have more tolerance for noise that is added further on into the link as you go through a cascade of optical amplifiers. So typically with our solution, you can get a longer reach than with competing solutions.
Great. That's great, Gert. Thanks for that. And Victor, maybe to follow on from Gert's input, if you're using Gert's 400 gig optics in one of Nanda's switches with OCNOS, is there an option to tune those transceivers using IPI's OCNOS?
Yeah, thanks, John. And yeah, definitely, just like Gert just mentioned, we continuously see that there is a big progression in development of these coherent technologies. So we have them. We see that there are much more capable transceivers coming in and also much cheaper transceivers coming in. So yeah, we definitely, aside from just offering a plug and play experience, now we have to offer a deeper integration, because now these transceivers can be managed for sure. So it becomes a general feature among the ZR+ transceivers to be managed, because there is such a big variety, and we need to make sure that they are all interoperable. So the fine tuning allows us to find the best balance between the quality of the signal, transmission distance, interoperability with the existing optical network, and also even we can extend the lifespan of the laser element for every application that we need, right? So these 4 items can be tuned. So to do that, we offer several tuning elements that are essential. Is a laser tuning and frequency grid tuning. These are for wavelengths. Also, we offer the output power tuning and modulation and forward error correction adjustments. So these are all that can be adjusted using our CLI. And pretty much any partner who is working with us, whenever they reach out to us for the CLI, we are ready to provide it to them, and they can do the fine tuning by themselves or with our optical partners. And also, additionally, we offer several monitoring and diagnostics, right? Because these are smart transceivers. We can extract a lot of more data from them, like from general performance monitoring. We also can extract various alarms. And we too also now they can do the self-diagnostics data, like loop back or random binary sequence, like PRBS. And also we can set up various user thresholds. So there are a variety of different management and performance control tools are coming in right now.
That's great. Thank you, Victor.